Hello, my name is William and today I will present an example to use the RUBEM Hydrological Plugin in QGIS. Here I'm using the QGIS 3.16. In the description of this video you can find the dataset inputs to download, and also we will use the Ipojuca River Basin dataset input, and this is an important watershed in Brazil. This watershed has had two hydrological zones, so it is in this video I only present how to input the data in the plugin, in the RUBEM Hydrological Plugin. And it is important to remind the pre-processing, it's not shown here. You can find the pre-processing procedures in the plugin documentation, and also in the description of this video you can download the dataset inputs file. So here we start with open the plugin. You can open the plugin from this icon here, RUBEM Hydrological, or you can go to the plugin tab, RUBEM Hydrological, and then RUBEM Hydrological. This is the tab of the plugin hydrological, RUBEM Hydrological. So to start we need to create a new file, new project. So we click new, and then there is a message if there is some change it will be lost, so you need to choose cancel or OK if you need to save something before starting with this project in the RUBEM Hydrological Plugin. So I will click here OK, and then the field to and then I need to create a file. So I use the Ipojuca dataset input files. I select the Ipojuca. Here I have a file used to Portuguese version, so I will create a new one, call it test. So then when we create the project, the field is allowed to include the information. So we start selecting the input folder. So I will select here the input data in the Ipojuca basin. So input. Then we need to select the output folder. So then dataset inputs basin output. So select, then there is a message here because we already has the output files there, and then there is a message to say, oh, you have the files there. If it is okay, there will be removed, so or create a new one. So click OK, and then I need to select some files to model. We starting with the elevation map here, digital elevation map. So we need to create this map in map file. In the documentation it will be provided how to create these files using PC Raster. So to select the map here in the input dataset files, you need to click in these three dots and go to input file in Ipojuca basin, select maps. We are working with maps then, and there is the input data. So after to select, we need to select the same file, but here in raster format, in this case TIFF format. So in the same folder there is a DEM file in raster format, so there is okay. It is important to see there is a clone file. This clone is kind of mask of the domain of the basin. So we select this here in the map. So we go to the map and select clone folder, and there is the file clone. It is important to say, if is not selecting any station location, results will not create as graphical. So it is important, if you have some gauge stations to observed data, observed flow, it is important to select here and create a map in this location. So if there is no location at all, no files with graph will be created, only map results. So we'll select this station location in the map folder and then select station, and here's the file and open. So the next step, we'll select the grid size. As a distributed model, it is important to say to the model how size is the grid. In this case we are using 500 meters, and then after that we need to select or say to the model when start the modeling and when will be the end of the modeling. Remember, the RUBEM Hydrological Plugin, it's a monthly discharge model, so we select here in this data set January 2000 to December 2018. So this is the data set period of data. After that we can save the project here, save, and also if we need to do something we can close and then go to open and continues to fill the dataset inputs here. So we are continuous from here now. We can move to the next tab. Here is information from soil. So in this case we need to select the soil map, so we go to the map, there is a soil folder, and select the soil map. Also here we need to fill some bulk density, saturate hydraulic conductivity, other information about the soil. So in this case it is different, it's not a map file, it is a text file. So we select here in the input data, text, and select soil information. In this case we are selecting the bulk density, so bdense file, open. Also the hydraulic conductivity, so in this case key set, just check key set, okay. Also the field capacity, so field capacity TFC, the wilting point file, saturate content Tset, and the root zone, the depth of root zone GPZ. Okay, so there is other information here about the initial condition of the soil as the base flow, this initial saturate zone storage. So here I'm leave as the standard values, but in the paper we present the range of the values, the minimum and the maximum values. So here just to show how to RUBEM works, I just leave as all, so we can save and move to the next one. So the next one will be the land use, the cover map. So in this case we need to select the cover map. RUBEM allow to use land use and then land cove at monthly basis. So we could change the land use for each month or each year, depends on how your project was done or you need to do. So in this case we'll select here a time, the folder in map, input map, and in this case it's land use. We need to show the land use map here, open, and then it's NVDAI, the index of the vegetation. We need to select the folder, the file, sorry, maps also, NVDAI, Here we select the maximum NVDI in the same folder, in this case NVDI max, and the minimum NDVI minimum. Okay. So there is others information here. It is the impervious area fraction, the open water area, the bare soil area. So all this file here, it is a test file, not a map file. So we need to select these files, but in the input folder and text files, in this case about the land use. So we're starting with the impervious area fraction, EI. So select the file and open, and we do the same for the others. AO, AS, AV, and then we need to select the main file. It's the roughness of the surface, and also some crop coefficient, the QC maximum and QC minimum, starting from QC maximum, max, and QC minimum, Okay, then there is other information here. We can leave as standard values, just as an example. So we can save here and then move to the next tab. This tab here, it is information about the climate. So we need to remember the RUBEM Hydrological, it's working only for rainfall. There is no snow melt procedures here, calculations. So we need to take that in consideration, and then select the monthly map from the rainfall. So here we go to the map folder in the Pojuca Basin and select the precipitation. There is a mistake, we need to fix that, but for the video we are considering this file here, it's only for the rainfall. So select open, then we need to select the potential and evapotranspiration. So we get to ETP folder, select the file, then we can use the QP coefficient. So it's another one here, QP, select, open, and then the rainy days. In this case, the rainy days, it's a text file, so we need to remember to go to the text file, and then here's the file, rainy days. Okay, we can open. So remember to save your project. If you have some problems in your computer, you can open again and start and continues from you stop it. So continues here for the next tab. There is a parameters tab. These parameters, it's used to calibrate the model. Remember, the calibration of the process to calibration is very important in modeling, in hydraulic modeling, because here there is these parameters. It's here these parameters. It's a configuration to calibrate your model. Calibration process, it's important to results from the simulation get closer than observed data. So in this case I will leave standard values just to show how the plugin works. The next, before save, and then we can run the model. It's important to see if there is options to select the results to generate the files. If we not select some information here, some parameters of the model, it is important these results will not showing in the graphic. The graphic will be shown to the station's location was pre-selected. In this case, we need to select what we want to see in graphic and map results. So if you not select a specific parameter here, there is no results information for this parameter. So here I will select all the parameters here and then click to run, and there is a message here saying the output folder the here there is a message say there is files in the output folder, and these files could be removed or changed. So I will agree with this message to allow the model run. Click OK, and the model is starting. So we need to wait now the modeling and to have the results. Okay, here the model was finished. So in this case was 228 steps from the beginning of the period simulation to the end. Remember, January 2000, December 2018. So the model ran very well, 68 seconds, and then we can go to the tab results to see the results. I will start in here with time series results. It's the graphic results. So we can select the parameter here to see the graphic results and double click, and for each one of the station there is the results for each one of them from the start January 2000 until December 2018. This is the runoff results for each one of the station 1, 2, 3, 4 and 5. And also we can see the other parameters, as for instance the recharge. Remember, the recharge here is the total recharge, it's not divided, and for each one of these it's the local station. So these results, it is in the pixel was selected the station. We can also see the base flow for each one of the station. So here are the results, and we can see also the map series results. In this case there is a map, a spatial results for each one of the time steps. So the results 1 will be the first month of the period of simulation, in this case January 2000, and then we can continue from that. So I will close here to see better. So we can see the results here in the map series results. We can open here a file, double click, and the file will be loaded in the QGIS canvas. And also we can see other parameters, as for instance actual evapotranspiration. We can select one here like 59, and to see better we can close here. Yeah, there is no problem. Cancel. Yeah, save it. Okay, so now we can do the configuration to see what's happening with the runoff. For instance, in this case I will select the blue color and classify, and okay, we see here the spatial results to runoff from the model, and this is the Pojuca basin. So we can also see the actual evapotranspiration. We can do here some configurations to see better. In this case in this case I will use another color, for instance reds. Click OK. Okay, so we can see here the results specialized for the RUBEM model. I appreciate your visit here. You can see in the video description the links to download the dataset input files, and also the paper and the documentation of the RUBEM Hydrological plugin in QGIS. See you, bye.